All right, so thus far we've talked about just a regular octahedral complex, and we've said that there's a low-lying T2G set and a higher-lying EG set, and they're separated by some energy difference called delta octahedral. We haven't really talked yet about why or what factors, as far as the ligands, affect this value of this delta octahedral. And our first ligand that we'll talk about is ammonia, and ammonia is what we call a pure sigma donor ligand. A pure sigma donor has one and only one lone pair on the donor atom, and so it cleanly forms a single bond to the metal you think of. Let's now talk about something like having 6 chlorides around the metal in an octahedral arrangement. And that will look like a lone pair from the chloride donating into the metal center. But we've also got, at right angles to that lone pair, we've got these lone pair on top, lone pair on bottom, that also does a type of pi donation into the metal center. So we have a sigma bond that's formed by one of the lone pairs, and then say the other two lone pairs are forming a pi bonding interaction. And let's see what this does to the energies. Well, to a first approximation, it doesn't do anything at all to the EG set. The EG set stays in place. So this empty EG set stays in place. The T2G set, which is going to be filled, undergoes interactions like this, where we have a filled orbital on the metal interacting with a filled pi orbital on the chlorine. And this drives the energy of these up. Okay, and so since EG stays the same, T2G goes up in energy. This leads to a delta octahedral that's small. Okay, well, we have one other situation that can happen. So if we have a metal with something like 6 CO ligands around it, and it's going to look something like this, where we have the metal, we have the lone pair from carbon monoxide donating into the metal, and we have an empty pi star orbital interacting with a filled metal orbital. And what ends up happening here is we push the lone pair into the metal, but the metal then has a filled pair that's in a T2G that gets vacuumed out onto the ligand. Let's see what the consequences of that is. So to a first approximation, again, EG stays the same. The T2G set gets stabilized from this interaction. So EG stays the same, T2G comes down in energy. This leads to a delta oct, which is large. Okay, and so it ends up then that from this we have 3 classes of ligands. So we have things like chloride, Cl minus. Water can act also as a sigma and pi donor. So one lone pair forms the sigma bond, a second one goes in and forms a pi bond. So water can also act as a pi donor like this. And what else can act as a pi acceptor? We call this a pi acceptor ligand. Okay, what else can act as a pi acceptor? Well, of course, things that look like this. So cyanide would be the same deal, Cn minus. Also has a low-lying pi star orbital, and this orbital can pull electron density off. But really anything that has a double bond to the donor atom can do this. So another one that can do this is pyridine. Pyridine, it's a six-membered ring like benzene that has pi bonds all the way around, and it's got a lone pair here that can donate into a metal center, and it's got a pi bond. If there's a pi bond there, there's also a nearby pi antibond, and so it also is a pi acceptor type of complex. So what you want to think of, delta oct, is right in the middle if you have a pure sigma donor, so ammonia or different amines or ethylene diamine. So all donors that have a single lone pair would belong to this group, would be sort of in the middle. If it's a pi acceptor, meaning if it has pi bonds in the ligand to the donor atom, then it is a pi acceptor and this delta octahedral will be large. And then if it is a pi donor, meaning that it has two or more lone pairs on the donor atom, so one to donate the sigma bond, one to donate a pi bond, would be that. And so Cl, example Cl, water, hydroxide, those would be, we would expect to be a small delta octahedral. Things like ammonia would be here in the middle, and then things with a large delta octahedral would be CO, Cn minus, and pyridine.